Let's take a few minutes now to talk about the vocabulary involved with circles. And as all of you probably know, a circle is simply a collection of points, and this is an infinite supply of points that are all equally far or equidistant from some central point. And together they form a circle. And there are several different segments that play prominent roles in circles. The first, as you can probably guess, is the diameter. So I'm going to draw a diameter here, and it should go through the center of the circle, and it is the longest segment you can draw through a circle. Now, in addition to the diameter, we can also draw what's called the radius, which is a segment that goes from the center of the circle out to a point on the circle. And the radius is half the diameter. In addition to these two types of segments, we can also create something called a chord. And a chord connects any 2 points inside or on a circle. And here's an example of a chord. And chords can be long, they can be short. Here's a very short one, for example, and then here's an even longer one. And as you can tell, the longest chord in a circle will be the diameter. And then in addition to these segments, we can also draw a segment that cuts through a circle. So I'm going to draw one here, and that's called a secant. And the word secant comes from the Latin root secare, which means to cut. So this is a line or a segment that cuts the circle and intersects it at 2 points. And then finally, we can draw something called a tangent. And a tangent actually just touches a circle at 1 point and then continues on forever. And so it has 1 point of tangency, and the spelling for tangent is T-A-N-G-E-N-T. And the word tangent comes from the Latin root tangere, which means to touch. And collectively, these 5 different segments, or lines, as the case may be, are used a lot in circles, and we'll be seeing them over and over again in the coming weeks. One interesting feature of tangent lines is that where they hit the circle, if we were to draw a radius back to the center, that radius makes a right angle with the tangent line. And I could repeat that process over here. They're supposed to meet there. I didn't draw that terribly well. And draw another radius hitting down there, and they also make a right angle. And it turns out that these 2 pieces of the tangent lines are the same length. And here's why. We could actually create a couple of triangles in this picture. And we know, I'm going to change the colors here, we know that this segment is congruent to that segment because those are 2 radii of the same circle. We know they share this common segment, and they both have right angles. So by HL, these 2 triangles are congruent. And if these 2 triangles are congruent, then these 2 pieces that are corresponding parts are also congruent. So if we have a tangent to a circle and another tangent to a circle, and they emanate from the same common point, then those 2 tangent parts are congruent. The next thing I want to focus on is the perimeter of the circle. And as you know, the fancy word for the perimeter of the circle is its circumference. And the circumference actually sweeps out 360 degrees. And I'm going to put a couple of points on this circle, put A over here and B over there. And we can use 2 points on a circle to define an arc. And this arc right here we can call arc AB. And its notation would be AB with an arc symbol above it. And there's also another arc that's defined by A and B, and it's this arc. But this arc travels over 180 degrees. It covers most of the circle. And to distinguish it from this arc, which covers just a short distance, we'll need a 3rd point on the circle, and I'll put it way down here. And we'll refer to the longer distance, or the longer arc, as arc ACB. So it would be ACB. And an arc that travels more than 180 degrees around a circle is called a major arc. And one that travels less than 180 degrees, like this one, is called a minor arc. Now, we can actually quantify the measures of those arcs in degrees. And to do that, we need a central angle, or central angles. So I'm going to find the center of this circle just by eyeballing it. And I'm going to draw two radii that together connect A and B to the center. And that angle looks like about 90 degrees. I'm going to call it 88, just because I don't know if it's exactly 90. And if that central angle is 88 degrees, that means that this arc from A to B is also 88 degrees. And we could write that this way. The measure of arc AB is 88 degrees. And of course that means that the measure of arc ACB, the major arc, must be 360 minus 88, which is, let's see, 272 degrees.